So the title of my talk is The Human Manifold. You know, you always have to find grandiose titles for the kind of work that you do. Specifically, what I mean here by human manifold is the idea that we can now characterize people by an incredible number of measurements that we can take about them online, about their purchasing behaviors and the things they like and the movies they watch. And what we find, of course, is that there's a lot of correlations in this data, which means that there's a low-dimensional manifold on which maybe the 7 billion people of this planet are living, which allows us to do interesting things like analyzing it and making predictions. This is joint work with people at Microsoft, Yoram Bachrach and Pushmit Kohli, who is my honorable colleague sitting here. And people at Cambridge University who really played a major role in this work, Michael Kruszyński and David Stilwell. So I'll introduce what we did, show you some results and interpretation, talk a little bit about privacy implications, and then conclude. Apologies for my ignorance in the general field of social sciences, in particular to the gentleman over there. I hope my interpretations will not be too blunt, but at this hour I also feel that I need to provide some entertainment value. Okay, so if we get started. We are now characterized, if we are active online, by an incredible number of measurements that can be taken, in particular in the social media landscape, Twitter, Facebook, all of those things. That's all very well known, but of course also the searches that we do, the music we listen to, the books we buy, and so on. And the point of view that I take here is that each one of these observations spans some kind of dimension in the space in which you can embed human beings. And the human manifold is this low-dimensional structure in there that expresses the correlations among these. And so why would we want to look at this manifold? Well, there may be scientific reasons that drive this, because it may help us better understand human behavior. We're in this unique situation that we can now look at these billions of data points, literally, and begin to understand the commonalities and the differences between people. And in particular, I'll look at some psychometric measurements that we can now do at this unprecedented scale. Working for Microsoft, we are also interested in the business potential of these things. We can, for example, develop fine-grained models that are psychodemographic in nature, which go beyond just the standard demographics, but take into account other aspects as well. And maybe we can improve services if we better understand who our individual customers are. And the approach that I'm going to talk about here is the idea of trying to map this low-dimensional manifold using notions that we already understand. For example, notions from psychometric, such as personality, intelligence, happiness. I'm not saying we're really understanding these, but we have instruments to measure these. Maybe that would be more exact. So let's look at some of these. Here you see a very popular scale of personality traits, often referred to as the big 5 personality traits. And they are openness, conscientiousness, extraversion, agreeableness, and neuroticism, the inverse of which is emotional stability. And they pretty much mean the things that they're saying, but in particular, if you wanted a definition, probably the cleanest definition is they are what's being measured by a questionnaire that asks you questions about it, and for which we have a procedure to evaluate it. Personality is not the only thing. Let me give you another example of a dimension we might be interested in, which is intelligence. And that's always a little trickier to talk about, because if I tell someone you're introvert, they might agree or might not agree, but they might not be offended. Whereas if I tell someone they're low intelligence, then that might evoke a different response. So it's a trickier topic. Nonetheless, it's interesting. And we also know that IQ measurements are to be taken seriously because they are predictive of real-world outcomes, of success in academia, of success in general, professional success, even relationship success. So you may argue that there is not a single dimension of intelligence, and I would agree. Nonetheless, these measurements are interesting in a real-world context. So how is this measured? You've probably all seen it. Here's an example of an IQ test item. There's this matrix of 9 items here. The 9th one is missing. You have to fill in one of these possibilities. And the more of these you get right, the more intelligent you are, right? You've probably all been through it. Just as a little exercise here to check if everyone's awake. Who thinks that 1 here is the correct solution to this question? Major hint? Okay, these can be tricky. Good. So I've talked about this human manifold and how we have all of this data to characterize people within this manifold. But how do we get this interpretability, and how do we connect these two things, the high-dimensional data space on which we can take measurements and the interpretable dimensions? We really need a particular type of data set for that, and fortunately it exists. It's been collected by my colleagues at Cambridge University, and it's called My Personality. And it's a really powerful data set, probably the most interesting one I've come across in my career. And here you see the names of the people, again, who drove this. And it was generated by a Facebook app that has been running for over 6 years now, where people were given the opportunity to take certain psychometric tests, like a Big 5 personality test or an IQ test, and so on. And they were then asked if they would be willing to allow the app to take a snapshot of their Facebook profile. And so we have both the psychometric test results here for the participants, and we have, from their volunteered user profiles, their relationship status, age, gender, and other information, their Facebook likes, their friendship network, and so on and so forth, whatever you can get from Facebook. And it is this 2-part data set and correlating these things that I will talk about in the rest of the talk. Okay, so here's an analysis that we ran on it. And first of all, you need to understand that we can represent this data as a matrix, the input data, if we just concentrate on the Facebook likes for people. So we have a set of users here, roughly 60,000 in this example, and then we have a set of what I call likables, things that you might or might not like on this axis here, and there's a sparse matrix that is 0 if that person didn't like that thing, and 1 if they liked it. Now, we need to understand that by that we just mean having pressed the like button on Facebook. It doesn't mean that they don't like things they haven't clicked. So that's a bit unwieldy to work with such a data set. So the first thing we do is we use singular value decomposition to reduce the dimensionality of this data set, essentially going from very high dimensional, 55,000 dimensional vectors describing each user here, to a dense representation where we just need 100 dense components in this space here. So we've basically compressed the data from this high dimensionality into this low dimensionality. And it turns out that we can do that while retaining a lot of the interesting signal. And then in step 3, we really used rather standard statistical methods like linear and logistic regression to try and build models from these Facebook likes to various variables that we're interested in, including things from the Facebook profile, the age, the gender, political and religious views, relationship status, and so on, but also from the test results, the Big 5 personality, intelligence, satisfaction with life, and other things. So that's basically our experimental setup, and if you think in terms of this manifold metaphor, we go from this high dimensional space into a lower 100 dimensional manifold. It's still pretty high dimensional if I think about it. And then we're trying to find directions within that, and that's the regression step, that essentially correlate with intelligence, certain personality traits, and so on. That's what's happening here. I can't go into the details of the limitations of this study, but you surely understand that there's a lot of selection bias going on here. This is specifically computer users, Facebook users who are happy to take personality questionnaires. So it's not unlike the phenomenon of the weird people that are used in studies, which are basically psychology grad students. Okay. let's look at some results. And we had the good fortune, or maybe not good fortune, that this work received a lot of coverage in the press. And so I let someone else do the interpretation here, and then maybe talk a little bit through it.
And another one for big data. A University of Cambridge study analyzed what 58,000 US Facebook users said they liked and compared it to detailed profiles and personality tests that these users later took. And the result was surprisingly accurate estimates of race, age, political views, and even sexuality. Accuracy was lowest, about 60% when it came to predicting whether a user's parents were still together when they were 21. People whose parents divorced before they were 21 tended to like statements about relationships. Drug users were ID'd with about 65% accuracy, smokers with 73%, and drinkers with 70%. Sexual orientation was also easier to distinguish among men, 88% right there. For women, it was about 75%. Gender, by the way, race, religion, and political views were predicted with high accuracy as well. For instance, white versus black, 95%. Now, here's the key. The more you like something on Facebook, the easier you are to analyze. The correlation of someone's age to the model's prediction rises steadily as the number of likes to analyze increases as well. Ditto for gender. So keep in mind that just because you think you're not revealing a lot of personal details on Facebook, you're still spreading the word to the outside world as well as those online marketers. That is today's Off the Charts.
I don't know how she does it, but okay, so if we want to go through that a little more slowly, we looked at these binary variables, and in particular, you need to ask yourself what kind of measure of accuracy you use for this kind of thing. We used the area under the curve in particular because some of these attributes are very unbalanced. And so, for example, if you have a minority of people in one class and a majority of people in the other, then just predicting the majority class would give you a very low prediction error, but it wouldn't really reflect your ability to distinguish between these. And that's basically what the area under the curve type of measures address. What we see is that things like gender, the ethnic background, that these standard demographic traits are in fact relatively easy to predict here and can be predicted with high accuracy, which kind of confirms that those are interesting variables that have been used for a long time. She mentioned that these self-reported lesbian and gay variables, that it seems to be easier to predict here for men than for women. Interesting to see that things like political views and religious views can be predicted quite accurately. But I mean, this is not necessarily any kind of magic, right? In fact, it's guaranteed not to be magic. You know, if someone likes Obama, you know, it's not actually that hard to predict these things. So just to keep that in mind, right? Some of these signals can be fairly explicit. And then you have things like use of drugs, drinking alcohol, smoking cigarettes, and so on. We get some predictive signal here. But again, once you've figured out that someone is like a 12-year-old kid, then, you know, correlation carries you over that to that kind of insight. And then there were these interesting little signals about being in a relationship or not, or the question if the parents separated. Okay, and then we have these numeric variables. Prediction accuracy here was measured by the Pearson correlation. And here we have age, which is again a standard demographic and which can be predicted very well. And then we have these quantities associated with personality, and that's quite nice to see that we get a predictive signal here. In comparison, this is in some sense how the maximum accuracy you could have expected for these variables based on the inherent inaccuracy of the test. So these tests are also not perfect, and they have only some degree of internal consistency. And so these predictive methods reach roughly half of that potential maximum. And then similarly for intelligence and satisfaction with life. So interesting predictions can be made, but of course there's a lot of noise there as well. Okay, let's turn to something else.
Blockbuster revelation that people with many friends like Jennifer Lopez, while volunteers with few friends liked walking with your friend and randomly pushing them into someone or something. Hey, it's not their fault they don't have friends. Everyone they know it keeps getting randomly pushed into traffic. But most importantly, the study revealed what your Facebook likes say about how smart you are. Researchers found that high IQ corresponds to liking Mozart, science, and the Colbert Report.
What can I say? That's right, folks. I don't blame you. I am smart.
Okay, so two things about this. I hadn't realized this, but if you ever wanted exposure of your scientific work in the media, make the media part of your work. And they'll be happy to report, because that's their favorite thing, right? They create stars that they report upon them. The second thing is that the competition, The Daily Show, was also on the list for high intelligence. So now I would like to finish this part by just going through some of the likes that were associated with different attributes. And I don't want you to take this too seriously. I mean, what we took here, basically, we took the regression coefficients and look at the high ones and the low ones for the different attributes. And there are a lot of interesting network effects that may or may not invalidate some of this analysis. But it should be interesting anyway. So with intelligence, these likes are associated with high intelligence, and these are associated with low intelligence. And there's really some interesting stuff here. I mean, there is the Colbert Report and the Daily Show, science, as you might expect. The press just loved the fact that curly fries shows up here, and I leave it to you to believe if that is a valid signal or not. And then you have these really strange things like Morgan Freeman's voice. Is anyone here who likes Morgan Freeman's voice? Yeah, it's remarkable, isn't it? It's, I always found it to be absolutely fascinating. And then you, on this side, you have, that's always my problem at this point. I don't know any of these things. Well, actually, Harley-Davidson, I do know. And it was quite funny to see that when this was reported on, one of the local TV stations interviewed the Harley-Davidson dealer near Cambridge and asked what was going on and confronted them with these results. And he pointed out that a lot of Cambridge academics were his customers and that he was quite surprised as well. Let's look at some other dimensions. Happiness. So this is the satisfied side, and this is the dissatisfied side. It looks quite strange if you know a little bit about American politics to find certain characters here. But there's an interesting thing here about, Pride and Prejudice. You know, that is quite nice. But about being conservative, being Christian, athletic stuff comes in. So it's not implausible, but always keep in mind that these things are effectively self-reported, so we have to take that with a grain of salt. And then here, the dissatisfied things, always a bit sad to see that science is among the things that is associated with a degree of dissatisfaction. And then, of course, our competitors' products, as you can see here. Let's look at another one, extraversion. This makes a lot of sense, I think. Things like dancing, socializing, I feel better tanned, you know, at cheerleading, and so on. And then here's the list of my hobbies. Programming, video games. Well, you know, what can I say? Okay, let's do one. Now this is it. So if you are able, have the power to make this type of prediction, then you need to think about how that impacts people's perception of privacy or right to privacy. And there was quite a lot of reporting, and some newspapers just said, oh, how funny, curly fries and Indiana Jones, and we can make these predictions here, Pride and Prejudice here. But of course, there were people who commented on potential privacy implications. And in fact, that was also the premise of the paper, to point out that these things are possible and potentially dangerous. So user privacy is definitely something to think about here. And I don't want to discuss this in detail, just a few questions. And one question, for example, is, are users aware to what degree we can make these predictions? And I think very few in this room would be surprised that these predictions can be made, but is that true for non-experts as well? If they were aware of it, would they be happy for us to make those predictions? Would they still make their data public so that we could infer these things? Or maybe the opposite is true. Maybe these predictions really just summarize what people are trying to project to the outside world anyway. I mean, maybe not low intelligence, but some of the other dimensions. And finally, what we're of course struggling with is the question, if we can improve a service using these predictions, in how far is that a valid trade-off that we can make? Can we trade the user's privacy for improvement in service? What kind of communication between the company and the user needs to go on to make that a legitimate thing to do? And finally, there may be some technological ways of addressing this problem, but I don't have time to go into that. Okay, let me conclude. We're trying to map this giant high-dimensional manifold of human behavior to work out what are the commonalities, what are the differences, can we better understand human behavior, and if we can we make that useful for our products and services? We need to pay attention to this balance between privacy and the quality of service. And of course, this is really just maybe the 101 analysis of that type of data. There's much more. There are much more questions to be asked. One thing that we're thinking about is, can we create a new framework for human personality that is based on this data and not on the history of psychology, so to speak? Can we start from scratch and build such a framework that is both predictive and interpretable? Another question that we need to ask is, someone can really only like something if it ever gets shown to them. So is there a bias here that we're really modeling the data in the wrong way? Because while a 1 definitely means that someone clicked on it, a 0 doesn't mean that the person dislikes it. It just means that they maybe didn't have an opportunity to click on it. And finally, a very ambitious and difficult question. This is all correlational work. Can we discover causal relationships from this kind of data, and what would that look like? All right, thank you very much.
So thank you. We have time for a few questions. Unless questioners are worried about the information they will reveal about themselves by asking a question.
I would like to come back to something which you just mentioned at the end, that you were talking about reduction of dimensions, but in reality you just took those dimensions from psychology and other subjects. And have you seen really in your data some kind of dimensional reduction, other kinds of correlations than what you would expect from earlier studies?
Right, so we have two steps of, in some sense, dimensionality reduction here. One is what we might call an unsupervised step, which is the singular value decomposition. And there you can show that the data is, in fact, lower dimensional. You can make a plot of how much variance you lose with every dimension that you throw away. And from that, you can see that if you take 100 of 55,000 dimensions, you still preserve roughly 40% of the variance, or 30%. So in that sense, there is definitely a correlational structure there. But the interesting thing, and we haven't really been able to identify that, is, are there any interpretable new dimensions that just have been missed so far from the picture? And it's quite difficult to do this, even if we look over the data and think there might be something there that vaguely, from looking at the top 10 likes, we might characterize as maybe intellectual maturity, or that was one of the things we looked at. How do you validate that? Can you use maybe crowdsourcing and ask people if they feel that that is a valid dimension, or how they would name it? It's incredibly difficult to then really nail that, even if you see a dimension that seems to make sense to you. So I think they do exist there, but giving them a name and confirming that they are real is very difficult from a methodological point of view.
I really like the concept of the human manifold. I think that's very cool. But I noticed that when you use SVD, obviously your manifold is a linear subspace. And while it's very hard, there's lots of other ways of forming that manifold. I just wondered if you tried any other ways, nonlinear manifolds or anything like that, and compared the prediction results?
Yeah, we tried various types of clustering methods as well. I mean, there's always kind of the choice if you go for a continuous manifold type reduction or if you cluster things. That leads to very similar results. So I don't think it would, because the dimensionality is so high, I don't think it buys you that much to think about nonlinear manifolds. I know that in some systems that would be crucial. For example, if you look at reducing image data and there are certain low dimensional movements of bodies, say body configurations, then it would be crucial to have nonlinear. But in this high dimensional space, I don't think it buys you that much. The problem is, though, in this dimensionality reduction step, we disregard the things we actually want to predict at that point. So we also applied directly L1 norm regularized regression directly to the data, and that gives slightly better results if you do that. So there you don't do this intermediate dimensionality reduction step, but you let the regression algorithm figure out what features it needs to focus on in order to make the best prediction, and it can then do that for every target variable separately. So you kind of lose this general dimensionality reduction step, which is kind of interesting and also delivers interpretable results, but you can buy yourself a little more accuracy in doing that.
And just to add just quickly, did any of those components give you some picture of some dimension that was common across, that wasn't introvert or extrovert, but was?
I mean, we actually saw with these PCA dimensions, you get things that also influenced our downstream analysis. For example, it's language. You get language. When you apply this to US, you get Spanish versus English speaking. And things like that. So those are very strong separating things because there may be very little overlap between those likes in the population, and that gives you these strong components then. And then we found, more subtle stuff, as if something was related to something like intellectual age, it seemed to me, where you liked certain very childish things despite the age not being low and stuff like that. But yeah, that's hard to nail. I can only encourage people to look at this data set if you're interested and try to find more.